Good morning, students. Chapter 5, Magnetism and Matter. Yes. Chapter 1, if you know, and Chapter 2, when polar or non-polar molecules, dielectrics, when they are placed in uniform electric field, that we know that each and every molecular dipole will align in the direction of electric field. And yes, on surface there is free charge density. Due to that, on dielectric bound charge density is produced, so in dielectric resultant electric field increases. In dielectric resultant electric field is that, okay, that E is equal to E0 upon K, that E is equal to E0 upon K. Yes, we know about this. Yes, we know about this. Similar method is here for magnetization and magnetic intensity. What is magnetization and what is magnetic intensity? See, we will discuss today. Here, magnetization and magnetic intensity. If case 1, here I have one solenoid. Here I have one solenoid. Okay, so yes, solenoid having numbers of turns and cross-sectional area of solenoid A. And yes, current flowing from solenoid is IF. Current flowing from solenoid is IF, where IF is called free current. Why free current? Because we are free. We are free to flow any current in this solenoid. If you connect battery of respective voltages, then obviously the current flowing from this solenoid it will be free. Okay, means we can set value of current up to our choice. Okay, so yes, current flowing from solenoid is IF. Yes, inside solenoid, case 1, inside solenoid there is medium air. Okay, so medium inside solenoid is air. So yes, first case we have a solenoid. Having numbers of turns and cross-sectional area A, current flowing from it is IF, medium is air, and yes, length of solenoid is L. Then we know that magnetic field in solenoid, magnetic field inside solenoid, B0. Why B0? Because initially medium in the solenoid is at B0 is equal to mu0 NIF. Where what is N? Small n is equal to N upon L. Numbers of turns per unit length of solenoid. Clear about this? So yes, we know this equation. B0 is equal to mu0 and IF. B0 is equal to mu0 and IF. Clear about this? Okay. Now, B0 is equal to mu0 and IF I can write as small IF. Now what is small IF? See, small IF is equal to N IF. What is N? Numbers of turns per unit length. So what is NIF? It is current per unit length. So yes, it is free current. IF channel. So yes, it is free current. Per unit length of solenoid. Clear about this? So yes, case 1, we have one solenoid. Total numbers of turns N. Cross-sectional area A. Current flowing from it IF. Free current. Why it is free current? Because we are free to flow any current in this solenoid. Medium air. Length is L. So magnetic field inside solenoid B0 is equal to mu 0 n IF. That is, n is equal to number of turns per unit length. B0 is equal to mu 0 IF. Where what is IF? IF is equal to n IF. That is free current per unit length of solid. Clear? Now, what is magnetization? What is magnetization? See, case 2. Case 2. Inside this solenoid, the same solenoid, okay, one magnetic material is placed. One magnetic material is placed inside solenoid. One magnetic material is placed having same length and same cross-sectional area. So yes, inside this solenoid, one magnetic material having same length and same cross-sectional area is placed. Okay, so inside solenoid, magnetic material is placed having same length and cross-sectional area. Let's see what happens. We know that magnetic dipole in uniform magnetic field, torque is acting. Due to that torque, it will perform rotational motion until it aligns in the direction of magnetic field. Yes, we know. Here, in magnetic material, any object, it is made up of molecules are made up of atoms are made up of electron, proton and neutron. Yes or no? Yes. In such cases, electrons, yes, they are revolving in orbit. In chapter number 4, we have proved that moving electron produces magnetic moment. It produces magnetic moment. So yes, one electron produces magnetic moment. So in atom, total numbers of electron produces some resultant magnetic moment. So there is some resultant magnetic moment of one atom. Such vector addition produces magnetic moment of molecule. Such resultant magnetic moment of molecule produces magnetic moment of material. Again, electrons are revolving, so they have some magnetic moment. Magnetic moments, vector addition of electron gives magnetic moment of atom. Vector addition of magnetic moment of atom gives resultant magnetic moment of molecule, and then finally it gives magnetic moment of material. So when magnetic material is placed inside solenoid, due to magnetic field of solenoid, magnetic material is magnetized. Magnetized means resultant magnetic moment is produced. Clear about this? So yes, I am assuming that due to this current IF, yes, magnetic field B0 is in this direction, and in this magnetic material, magnetic moment produced is m. Total resultant magnetic moment produced is m. Yes, this magnetic material includes numbers of molecules. Each and every molecular behaves as molecular dipole. And due to this external magnetic field, each and every molecular dipole will align in the direction of magnetic field. So yes, resultant magnetic moment, it is in direction of magnetic field. Clear? So yes, due to magnetic field of solenoid, magnetic material is magnetized, that is resultant magnetic moment is produced. is produced. Okay, resultant magnetic moment, resultant magnetic moment M, resultant magnetic moment M is in direction of is in direction of each. Clear? Yes, magnetic moment is produced. It means if we compare again with the case of electron revolving, then yes, due to rotation of electron, current is produced, and due to current, magnetic moment is produced. So here we can make one reverse statement. In magnetic material, some magnetic moment is produced, means some current is also produced, and that current is called bound current. That current is called bound current. In this material, yes, in this material, some current that is called IB, bound current, is produced in this material. So yes, we can say in magnetic material, bound current IB is induced, which produces magnetic moment, M. Clear about this? So yes, in short, in solenoid, when a magnetic material is placed, okay, that material is magnetized. Means now it has some resultant magnetic moment. Okay. Now this resultant magnetic moment is M. What is magnetic moment? Resultant magnetic moment of material. M is equal to, equation of magnetic moment is NIA. Magnetic material, only one current will be formed, so it is 1. And I, it is IB. And A, cross section is same that of solenoid. So M is equal to is IB into A. Now one definition you have to remember. What is magnetization? Magnetization is capital M. Magnetization is defined as total magnetic moment per unit volume of magnetic material. Okay, so yes, it is one definition that you have to remember. Magnetization is defined as total magnetic moment per unit volume of magnetic material. That is N is equal to resultant magnetic moment is N, and V is volume. So is equal to, and this is equal to, it is IB into A. Volume. What is volume of this material? Length is L and cross sectional area is A. So it is A into L. A cut. So IB upon L. Yes, IB upon L. Bound current per unit length. I can write this as small n. Clear about this? Yes, if I want to write magnitude, then I can write also magnitude. Magnetization is equal to resultant magnetic moment per unit volume. IB into A upon L is equal to base IB. So here we have one important result, that magnetization is equal to bound current per unit length. Clear about this? Remember chapter 2, polarization. Inside capacitor, when non-polar or polar dielectric is placed, it is polarized. Free charge density, bound charge density, Do you remember? Polarization P is equal to sigma B. Polarization P is equal to sigma B. The similar result we have. Magnetization is equal to bound current per unit length. Bound current per unit length. So yes, you have to remember this equation that M is equal to, here it is IP. M is equal to, here it is IP. So now what happens? See here. Initially only IF current is flowing in, or initially only IF current is flowing in solenoid. When magnetic material is placed, now that material is magnetized, means there is some current flowing from that magnetic material, from the magnetic material, that is IB. That is IB. And as this V0 and M, they are in same direction, these two currents are also in same direction. So now when magnetic material is placed inside solenoid, resultant magnetic field inside core, magnetic core, resultant magnetic field inside core of material, inside core of material, I can write B is equal to mu 0 IF plus mu 0 IB is equal to, B is equal to mu 0 IF plus IB. Mu 0 IF plus IB. Mu 0 IF plus mu 0 IB. Clear about this? Okay, so yes, this equation you have to clear about this. Yes, magnetic moment, it is vector quantity. Magnetic moment is vector quantity. Here this magnetic moment, it is vector quantity. M is vector quantity, and its direction is in direction of M. In direction of M. That is net magnetic moment. What is its unit? See, what is unit of magnetic moment? Ampere meter square. What is unit of volume? Meter cube. So its unit is, yes, its unit is ampere per meter. Ampere per meter. Or how to easily define its unit? M is equal to IB. M is equal to IB. And what is IB? Bound current per unit length. Current per unit length. So what is unit of magnetization? It is ampere per meter. It is ampere per meter. Clear about this? So yes, again, quick revision. We have one solenoid. Initially, medium between solenoid is air. So what is magnetic field? Mu 0 small IF, where small IF is free current per unit length. When magnetic material is placed, it is magnetized. Some resultant magnetic moment is produced. So we can say some current is also produced. So what is resultant magnetic moment? Resultant magnetic field? B is equal to mu 0 IF plus IB. B is equal to mu 0 IF plus IB. Now we have to obtain its different form. That we will see. Resultant magnetic field inside core of material. Yes, B is equal to, it is mu 0 IF plus IB. But see, we have proved, okay, M is equal to IB. So here I will place B is equal to mu 0 IF plus M. Clear about it? Okay. Now B upon mu 0 is equal to IF plus M. B upon mu 0 minus M is equal to, here it is IF. And this B upon mu 0 minus M is called magnetic intensity. It is called magnetic intensity. Clear about this? This B upon mu 0 minus M is called magnetic intensity, and it is denoted by, M is denoted by H, is denoted by H. Clear about this? So yes, B minus B upon mu 0 minus n is called magnetic intensity and is denoted by H, is denoted by H. As M is magnetization, its unit is ampere per meter. So unit of H is also ampere per meter. Or we can say, see, this V minus mu 0 minus M is equal to IF and it is denoted by H, means H is equal to IF. Which is nothing but magnetic intensity, magnetic intensity means free current per unit length, So yes, you have to remember this. H is equal to IF. Okay. Now, magnetization depends on which factor? Again, we have solenoid. Inside solenoid, one magnetic material is placed. Okay. Initially, we have to supply some current in solenoid. Due to this current IF, magnetic field B0 produces. Due to that, each and every molecular dipole will align in direction of magnetic field. Resultant magnetic field produces. IB, bound current, produces. Due to that, we can say magnetization is achieved. Yes or no? So yes, magnetization, IF, and see, this is small IF, that is magnetic intensity, is free current per unit length. So yes, from experiments we can say magnetization is directly proportional to magnetic intensity. Okay. Bound current per unit length is directly proportional to free current per unit length. Okay. If we remove proportionality, we have to add some constant, and that constant is chi m. Where chi m is magnetic susceptibility. Where chi m is called magnetic susceptibility. And yes, it is again characteristics of medium, similar to electrical susceptibility. Now we have to combine such all equations. Again, I will write this equation. Okay, that is magnetic field inside core of magnetic material, that is P is equal to mu 0 IF plus IB. So B is equal to mu 0 IF, I can replace IF by H, plus IB, I can replace IB by M. So yes, here it is M. Clear about this equation? IF is equal to H, we have proved. IB is equal to M, we have proved. So yes, B is equal to mu 0 H plus M. Magnetization is equal to chi m into H. Clear about this? So yes, again H common. So B is equal to mu 0 1 plus chi m. Here it is into H. Clear about this? Now remember one equation. Initially, when current is flowing from solenoid and medium inside solenoid is only air, what is equation of P0? Here I will write B0 is equal to mu 0 IF. So I can write it is mu 0. I can write mu 0 H. Yes or no? But this equation is when inside solenoid medium is air. Now, inside solenoid, we have one magnetic material. So compare magnetic field is equal to H. What is mu 0? Permeability of air. So here mu 0 1 plus chi m, it is called permeability of medium material, permeability of medium or material. So I can write this equation as B is equal to mu h. B is equal to mu h. Clear about this? Remember again chapter number 2, epsilon 0 1 plus chi e is equal to epsilon, similar equation. Mu 0 1 plus chi m is equal to mu, where mu 0 1 plus chi m is called permeability, of material. It is called permeability of material. Clear about this? So now what is equation in medium? Yes, it is. B is equal to mu h. So very simple conclusion. When inside solenoid you have air, B0 is equal to mu 0 h. When inside solenoid you have air as medium, B0 is equal to mu 0 h. When air is replaced by another medium, B is equal to mu h, where mu is permeability of that medium. Simple conclusion. Yes or no? Yes, I can write this mu 0 1 plus chi m as mu. That is permeability of material. Clear? So now from this equation, if I make mu upon mu 0 as subject, it is 1 plus chi m. Mu upon mu 0, permeability of medium divided by permeability of air. It is called relative permeability. That is mu r is equal to 1 plus chi m. It is 1 plus chi m. It is relative permeability. Clear about this? It is relative permeability. Any doubt? So yes, what conclusion you have to remember? If it is solenoid, in solenoid initially medium is air, then magnetic field inside solenoid B is equal to mu 0 h. When inside solenoid that medium is replaced by another magnetic material, then magnetic field is equal to mu h. Yes, mu h. Mu upon mu 0 is equal to mu r. Mu upon mu 0 is equal to mu r. So what is mu? It is mu 0 mu r. So yes, B is equal to mu 0 mu r h. You can also use this equation. Clear about this? So yes, it is a whole theory. What is magnetization? What is magnetic intensity? You will be asked to prove this equation. Okay, when magnetic material is placed inside solenoid, prove B is equal to mu h. Clear about this? What is conclusion? If medium is changed, magnetic field also changes. Okay.